Hi students, welcome to Max Point of View. Today we are going to solve each and every numerical from the chapter Electricity Part A. Before watching this video, my suggestion is watch the concept video first, then understand all the theory question, how we have solved it. Then now we are going to solve each and every numerical from the chapter Part A, and whatever the numerical is there from the textbook, we are going to solve each and every question. So before starting our numericals, we need to understand the formulas and their units. Listen, I is nothing but current. What is the unit of current? Amperes. We are going to use all those units in the numericals, then you will understand. Q. Okay, Q is the charge value, number of electrons into value of one electron. If Q is given and time is given, we can aramse substitute and get the answer of I. If Q is not given, there is one more formula to find Q. Q is equal to N into E. Okay, in few questions we will get confused whether N value is given, Q value is given. Why? Because E value is constant, that is 1.6 into 10 power minus 19. Sometimes it will be given in the question. If it is not given, we can aramse assume it as 1.6 into 10 power minus 19 C. Okay, now if N value or Q value is given, if we get confused over that, then very simple. If N value is given, there will be no unit. Okay, it will be like 6.25 into some 10 power some value. Okay, if along with that value, if along with that value number of electrons, if you have unit C, okay, unit C, that means Q is given. Okay, next, V is equal to I into R. This is because of Ohm's law. Ohm's law states that current is directly proportional to potential difference, correct? So V is equal to I into R. V is nothing but potential difference. Potential difference is nothing but voltage. Voltage is equal to current into resistance. Okay, we have understood what is the function of resistance, what are the different types of resistors we have, all those things in the concept video. Then only we will understand all these things in a proper way. Then if R value is not given, how to find R value? R is equal to rho L by A. Rho means resistivity. The value of resistivity for a given question will be constant. This is L means length, A means area of the wire. That's it. If we know all these things, aramse we can solve our first question. In a conductor, 6.25 into 10 power 6 electrons flows from its end A to B in 2 seconds. Okay, and find the current through the conductor. E value is given. Okay, now listen. In a conductor, 6.25 into 10 power 16 electrons are flowing. That means, do you see any capital C unit? No, right? That means N value is given. N value is given. If the same thing, 6.25 into 10 power 16, C is given, that means Q value is given. So there is no unit. So first we will write the given data. So in the question, 6.25 into 10 power 16 electrons are flowing. That means number of electrons are flowing. C is not given, capital C unit is not given. That means N is given. If along with that value C is given, okay, unit C is given, that means Q is given. This is 6.25 into 10 power 16 electrons. Then E value is given, that is nothing but 1.6 into 10 power minus 19. We have to find, and time is also given. Time is 2 seconds. We have to find current. Okay, now see, whenever any question is asked and there is no direct formula for the given question, then we have to write the primary formula, main formula. From that formula, I will teach you how to derive the formulas. Okay, listen. I is equal to Q by T. If you follow this method, you will get the answer in a easier way. See, this is the main formula. To find current using time and charge, this is the main formula. Time is given means we have to use this formula instead of this formula. If voltage and resistance are given, then we can use this formula. But they are talking about time and number of electrons, all those things. So we have to use this formula. Here T value is given. Okay, Q value is not given. To find Q, we have one more formula, correct? Instead of Q, I'll write N into E divided by time. See, this time I have written as it is. Q value is not given in the question. See, if along with this value, if C is there, capital C is there, that means Q value is given. If not, N value is given. Okay, that is what we have understood, correct? Now Q value is not given. How we can find Q? Q is equal to N into E. N is given, E value is given, time value is given. Now substitute the answer, you will get the value of current directly. Okay, don't find Q first, then substitute in the formula, all those things. Instead of doing all those things, this is the easiest way to find the answer. So what is N? That is 6.25 into 10 power 16 into 1.6 into 10 power minus 19 divided by 2. Now 6.25 into 1.6, see 10 power 16 into 10 power minus 19, it will be 10 power minus 3 by 2. If you solve this one, you will get the answer as 5 into 10 power minus 3. Okay, and what we are finding? Current. What is the unit? Ampere. See, what do you mean by 10 power minus 3? 10 power minus 3 is nothing but milli. 10 power minus 3 in terms of milli. So 5 milliamperes. You should know some prefixes, positive prefixes and negative prefixes, like 10 power minus 3, 10 power 6, 10 power minus 6, 10 power minus 9, 10 power plus 9, 10 power 3. All those prefix values you should know. Then it will be very easy. Our second question, a current of 1.6 milliamperes flows through a conductor. Okay, they are given, second question, right? They have given current value, that is 1.6 milliampere. What is this? Milli into 10 power minus 3 amperes. Next, if a charge of electron is 1.6 into 10 power minus 19 coulomb. Listen, a charge of an electron value is given. If one electron value is given, that means we have the value of 1.6 into 10 power minus 19 coulomb. That is nothing but one value of electron. They have given minus 1.6, correct? See, the sign of electron is negative. That is what they have given, but we don't have to use that negative sign in the numericals. Next, find the number of electrons. Find the number of electrons, N value, not Q value. Number of electrons means N, number of electrons will pass in each second. That means time is given as 1 second. Okay, using all these things we have to find the value of N. See, what is the main formula? I is equal to Q by T. Q value is not given. E value and N, they are asking N value, E value is given. So Q is equal to N into E by T is equal to I. What we want? Value of N, correct, number of electrons. So move these to that side. I into T divided by E is equal to N. We'll substitute the values. N is equal to I is nothing but 1.6 into 10 power minus 3. T, each second they are asking, right? That means 1 second divided by E. E value is given as 1.6 into 10 power minus 9. 1.6 get cancels. This 10 power minus 19 goes to the numerator, becomes 10 power plus 19. So 10 power minus 3 into 10 power minus 9 plus 19 will become 10 power 16 electrons. That's it. The N value is equal to 10 power 16. You can aramse write in the exam conclusion, the number of electrons flowing in each second is 10 power 16. That's it. Question number 3. Find the potential difference required to flow a current of 200 milliamperes in a wire of resistance 20 ohm. Very direct question. Listen, first we'll write the given data. Current is given. I is equal to 200 milliampere. R is equal to 20 ohm. Then we have to find potential difference. Potential difference is nothing but voltage. What is the formula? See, we need to find potential difference. Current and resistance are given. V is equal to I into R according to Ohm's law. So this one we are going to use in part B and part C also. Okay, listen, I value, that is 200 milli. Milli means 10 power minus 3. If you miss this one, definitely everything will be gone. Into R, that is 20. So these two, only these two, okay, into 10 power minus 3, the answer will be 4 volts. That's it. See, if you know the proper formula, substituting and getting the answer, that's it. Part A and Part C numericals are very easy. Part B, little advanced question, but Part B requires a lot of understanding. If you have that knowledge, any question you can easily answer. Question number 4. An electric bulb draws 1.2 amperes current at 6 volts. Find the resistance of the filament of bulb while glowing. Whatever the question is, first write the given data and what we have to find. If you know that, answer we can answer it. Current is given, I is equal to 1.2 amperes. Then voltage is equal to 6 volts. We have to find the value of resistance. That's it. See, the same formula. V is equal to I into R. We need R. So R is equal to V by I. R is equal to, what is the value of V? That is 6 divided by 1.2. The answer will be 5. What is the unit of resistance? That is ohm. That's it. See, substitute, get the answer easily. Question number 5. A car bulb connected to a 12 volt battery draws 2 amperes of current. Okay, first we'll write the data. Voltage is equal to 12 volt and current is equal to 2 amperes. Now we'll continue. What is the resistance of the filament? We have to find the resistance, and they have one more question. First we'll solve this question, then we'll go for the next sub question. The same method. V is equal to I into R. R is equal to V by I. See, few times I have seen students to take V by I, they'll take I by V, all those things. Properly you take the formula, substitute it and get the answer. V is nothing but 12 and R is nothing but 2. Then answer will be 6 ohm. Now this is the answer for the first sub question. Second sub question. Will the resistance be more, same or less when the bulb is not glowing? What do you mean by bulb is not glowing? It doesn't mean bulb is damaged. It means the circuit is open or switch is turned off. When the switch is turned off, the resistance will be less. So answer for this question will be resistance will be less. Question number 6. Calculate the current flowing through a wire of resistance 5 ohm connected to a battery of potential difference 3 volts. Okay, very direct question. We need to find the value of current. R is given as 5 ohm and voltage is given as 3 volts. Write the primary formula, or else you can write the direct formula. I is equal to V by R. Again I am telling you, few students will write it will R by V, all those things. Try to avoid those mistakes, because these kind of mistakes will make you not to score 80 on 80. So patiently you can solve, because when it comes to physics exam you have lot of time. The questions will be very logical, very simple, with one word only you will get the answer. So in those kind of questions aramse you can save time. So go patiently. Next, V is equal to 3, R is equal to 5, answer will be 0.6 amperes. That's it. Question number 7, a graph based question. See, in ICSE these kind of questions will not be asked in the board exam, but for the safer side we are going to learn it. Okay, listen. They have given a table, potential difference, that is nothing but voltage. For this potential difference, respective current is given. Like that we have 5 different potential difference, 5 different respective currents. Okay, now we'll see the question. First we have to draw the graph. Okay, listen, VI graph, we have to see properly in the exam whether they are asking VI graph or IV graph. VI graph means V will come in y axis and I will come in x axis. IV graph means I will come here, V will come here. Even though the graph is same, the x and y axis values will be completely different. We have to be very careful. And I have written V values and I values accordingly. Now for 0.2 current, what will be the voltage? That is 0.5. For 0.4 it will be 1, and for 0.6 it will be 1.5. For 0.8 it will be 2. For 0.1 it will be 2.5. Okay, see, once you draw this one, okay, once you put the dots, join them. I have not taken the skill, that's why I'm getting I'm not getting straight line. If you take the scale and proper measurement, you will definitely get a straight line. These kind of graphs are called linear graphs. Linear graphs. What do you mean by linear graph? Linear graph means using V and I, what we can find? Resistance. At what point? You can take any point. You can take any point. At any point, the resistance value will be same. This is nothing but a linear graph. Okay, it will start from the origin and exact 45 degree. This is nothing but linear graph. Okay, graph is done. Now we'll go for the question. A potential difference V when the current is 0.5. See, 0.5 amperes is given? No, right? So 0.5 lies between 0.4 and 0.6. Correct? 0.5 amperes lies between 0.4 and 0.6. So somewhere exactly at the middle. Take the middle value of this one, because it is linear graph. All the values will be whatever the values we are taking here, the same corresponding value we are going to get. See, when they are talking about current is given as 0.5 amperes, we need to find voltage. Okay, current 0.5, it is between 0.4 and 0.6. Correct? So here take the middle value of these two, 1 and 1.5. what is the middle value? That is 1.25 volts. That's it. In the same way, second sub question, current I when the potential difference is 0.75. When it is 0.75 volts, we need to find the value of current. Where is 0.75? 0.75 potential difference, that is voltage, lies between 0.5 and 1, exactly at the center. Take the center value of 0.2 and 0.4, that is nothing but 0.3 amperes. That's it. Now current resistance in the circuit. Third sub question, resistance in the circuit. See, as this is a linear graph, okay, you can take any value, any two values to find resistance. If you take this value, you will get the same resistance. You will get this value also, you will get the same resistance. I will show you. See, we will take these two value. R is equal to V by I. Correct? V is nothing but 1 by 0.4. Correct? Potential difference is 1. I is 0.4. The answer will be 2.5. Okay, you can take these two also. See, voltage is 2.5. 2.5 divided by 1, 2.5. The same answer you are going to get. So hence it is a linear graph. You can take any 2 points to find the value of resistance. Question number 8. Two wires of same material and same length have radii 1 mm and 2 mm respectively. Compare their resistance and their specific resistance. So here a few words you need to understand. What do you mean by resistance and specific resistance? Resistance is normal resistance. Specific resistance means resistivity. Okay, they are talking about resistance, resistivity, length and radii. Radii is nothing but it related to area. Correct? So they are talking about length, area, specific resistance and also resistance. Which formula we have to use? This formula. So this is the formula we have to talk about here. So if the material is same, specific resistance will be same. Specific resistance is nothing but this one, that is nothing but resistivity. Resistivity is equal to specific resistance. Both are same. Don't get confused whether they are talking about resistivity or resistance. Specific resistance is nothing but resistivity. For a same material, resistivity or specific resistance remains same. Assume a copper of 5 meter wire and copper of 10 meter wire. We are talking about same material, right? So the resistivity will be same, only the resistance will be different. So keep one thing in mind that will be useful for the next sub question. So first one, we have to compare the resistance. Correct? They are telling length is same, so we can remove from the formula. Whatever will be same, we can remove from the formula. And we know same material, so resistivity also will remove. So finally resistance will depend upon only area, that too inversely proportional. So we are talking about two wires. R1 will be 1 by A1. Okay. R2 will be equal to 1 by A2. They have given the area? No, right? They have given the radii. Radii means two different radius. Next, how we can get the formula of A? Area is nothing but pi r square. Pi r square is nothing but the area of a circle. So whenever you cut a wire, it will be in the form of circle, right? That's why we are using area as pi r square. Next, this one, we'll take this one as 1 and this one as area of second radii. Okay, next we'll substitute the values. 1 by first radii is 1 mm, so 1 by 1 square, and the second radius is 2 square, 2 mm, so 2 square. Okay, now this will be 1 by pi and this will be 1 by 4 pi. Correct. This is the final values. What do you mean by comparison? We have to write the answer in ratio form. So this will be 1 by r1 by r2. What is the value of r1? That is 1 by pi. What is the value of r2? That is 1 by 4 pi. See, instead of division, I'll multiply and take the reciprocal. I'll write the first value as it is 1 by 5. Instead of division, multiplication, 1 by 4 pi will reciprocal. We'll take the reciprocal. So pi and pi will get cancelled. What is the answer remain? 4 by 1. So 4 by 1 is nothing but 4:1. See, all those steps you don't have to show in exam. Okay, substitute the here. Okay, substitute here. Okay, like this, substitute like this, substitute the values, directly write the answer. Without all this calculation, you will definitely get full marks. Okay, because these questions will be there for 1 or 2 marks. The substitution you will get definitely 1 mark. Final answer will get 1 mark. In middle, whatever the calculation we do, it will not give you any marks. Okay, we'll go for the second sub question. This is first sub question. Second sub question, they are talking about we have to compare their specific resistance. Specific resistance is nothing but resistivity. For the same material, specific resistance will be same. If the value is same, answer will be 1:1. Write it in the bracket. For the same material, specific resistance will be same, so 1:1. That's it. Question number 8. Two wires of same material and same length have radii 1 mm and 2 mm respectively. Compare their resistance and their specific resistance. So here a few words you need to understand. What do you mean by resistance and specific resistance? Resistance is normal resistance. Specific resistance means resistivity. Okay, they are talking about resistance, resistivity, length and radii. Radii is nothing but it related to area, correct? So they are talking about length, area, specific resistance and also resistance. Which formula we have to use? This formula. So this is the formula we have to talk about here. So if the material is same, specific resistance will be same. Specific resistance is nothing but this one. That is nothing but resistivity. Resistivity is equal to specific resistance. Both are same. Don't get confused whether they are talking about resistivity or resistance. Specific resistance is nothing but resistivity. For a same material, resistivity or specific resistance remains same. Assume a copper of 5 meter wire and copper of 10 meter wire. We are talking about same material, right? So the resistivity will be same. Only the resistance will be different. So keep one thing in mind that will be useful for the next sub question. So first one, we have to compare the resistance, correct? They are telling length is same, so we can remove from the formula. Whatever will be same, we can remove from the formula. And we know area will decrease 2 times only. If the length increases 3 times, then area will decrease 3 times. Vice versa. If area increases 2 times, length will decrease 2 times. That's it. Now you need to know this one. Initial value of length is L. Now it is 2L. Initial value of area. Okay, this one. This area is A. Now it is A by 2. Correct. If the length increases 2 times, area decreases 2 times. So now I told you, right, if you understand this concept, then there is a formula. R nu is equal to, see, whatever the formula I am going to write, I created this formula. This formula is not available on the Google also. Listen, while solving many questions only, I got to know we can use a formula instead of going for a calculation method. Listen, to find new resistance, write the old resistance value into new length nu by area nu. Why I have to divide length by area? Because this is the formula. See, we are talking about resistance, length and area, and we are not talking about resistivity or specific resistance, right? Remove from the formula, then R is equal to L by A. So to find new resistance, old resistance into new length and new area, we'll substitute the values. Old resistance is 1 ohm, new length is 2L. See, assume initially whenever we don't know the value, assume it as 1. Initially the length was 1 meter, now it is 2 times the length, that is nothing but 2. Then area, initially assume it as 1, now it becomes 1 by 2, that is nothing but half, correct? So it will become 1 into 2 into 2, the final answer will be 4 ohm. That's it. See, if you understand the concept, substituting the values in the formula, see this formula I created it, it's not available on the Google also. So very simple, new resistance is equal to old resistance into new length divided by new area. That's it. New area, new length, completely based on the concept. If you know the concept only, if the length increases 2 times, area will decreases 2 times. All these things you should know. Okay, based on that we are going to substitute the values. Okay, if you get confused, watch it one more time, definitely you will understand. Question number 10. A wire of resistance 3 ohm and length 10 centimeter is stretched to length 30 centimeter. Assuming it has uniform cross section, what will be new resistance? Very important question. Compared to previous question, there is one change, you need to understand that. Question number 10. So the resistance is, present resistance is 3 ohm, the length, present length is 10 centimeter, new length is 30 centimeter. You can take it as 1 centimeter and 3 centimeters. See, when it comes to these kind of questions, the value of length and area will not be a matter. If you use also, you will get the same answer. If you assume it as 1 centimeter also, you will get the same answer, because 3 times it is increasing. We are going to use 3 times only. See, what is the formula we used? New resistance is equal to old resistance into new length by new area, and area they have told it is uniform. Uniform means area is not going to change. Area is not going to change, only the length is going to change. Whenever they tell, this logic you are going to use, listen carefully. Whenever they tell area is uniform, that means length become square. Whenever the same formula only, whenever the area get cancels, length becomes twice, square of it. So old is, keep this in mind. See, the proof you don't require, you need to understand the logic. Whenever they say area is equal to uniform cross section, then new length become new length square. Keep this in mind. Next, old resistance is 3 ohm and new length. See how many times it has increased? 3 times. We don't require this value also. How many times it has increased? 3 times. So 3 square. So 3 into 9, that is 27 ohm. Okay, see these kind of questions without formula also we can calculate the answer, with formula also we can calculate the answer, but in the board exam we will get full marks for both the methods. Question number 11. A wire of resistance 9 ohm having length 30 centimeter is tripled on itself. Tripled on itself, what is its new resistance? Very good. Question number 11. Old resistance or present resistance is equal to 9 ohm. Okay, now so assume this is the wire of resistance 9 ohm. Now what do you mean by tripled on itself? Tripled on itself means folding one on the other 3 times. See, I'll cut this one into 3 equal parts. So this is the meaning of tripled on itself. So this is the length, 3 times I have to divide it equally. Once you do that, tripled on itself, one on the other. So this is the new this one area of the resistance. So here L, assume it L as 1, always 1, and area as 1. Now L has become reduced 3 times, area is increased 3 times, correct? See, the length decreased 3 times, the length decreased 3 times, and the area, this is the area, right? Area is increased 3 times. If you know this one with the values or without the values, length is equal to 30 centimeter, without that also we can get the answer. The same logic, new resistance is equal to old resistance into new length by new area. See, in this question, area this one wire is not uniform, so we are going to substitute the values. Old resistance is equal to 9, new length is equal to L by 3. Okay, if we don't know the, okay, if we know or we don't know the value, assume it as 1 length. Now area 3a. So listen, 9 into area also we assume it as 1, so 3 into 1 will get 3. 9 into 1 by 3, right? So it becomes like this. So 9 by 9 is equal to 1 ohm. That's it. See, the same formula only we can get the answer for every question. Question number 12. What length of copper wire of specific resistance 1.7 into 10 power minus 8 ohm meter and radius 1 mm is required so that resistance will be 1 ohm. So we need to find the value of length. Question number 12. Length we have to find. Okay, what is given? Specific resistance is nothing but resistivity, that is 1.7 into 10 power minus 8 ohm meter. Then resistance is also given, R is equal to 1 ohm and radius is given, that is 1 mm. 1 mm is equal to 1 into 10 power minus 3 meter. We have to convert this into meters. This is very much important. If you don't convert it also, you will get the answer, that will be wrong. If that is also, you will get the marks, that will be 0. So convert this into meters, SI units. Now what is the formula? R is equal to rho L by A according to this formula, correct? Here we need to find the value of L. So we'll send rho resistivity or specific resistance and area that side. These two will become reciprocal. So L is equal to R into A by resistivity. We'll substitute the values. So here R is equal to 1 and area is equal to, what is the formula for area? Pi R square by resistivity, that is 1.7 into 10 power minus 8. Now listen, 1 into pi value 3.14 into R. R is nothing but 1. So you should not take millimeter, you should take the value in terms of meter, that is 1 into 10 power minus 3 meter whole square by 1.7 into 10 power minus 8, correct? I'll write all these things here. So 1 into 3.14 into 1 into 10 power minus 6 divided by 1.7. I'll send this 10 power minus 8 to the numerator, that becomes plus 8. So if you solve these things, okay, if you solve all these things, answer will be 184.7 meter. That's it. So if you know the logic, substitute the proper answer, go for the calculation. That's it. Question number 13. A filament of bulb takes a current of 100 milliamperes when the potential difference across it is 0.2. First we'll write that. So this is question number 13. I is equal to 100 milliamps when the voltage is 0.2 volts. Next, the potential difference across it becomes 1 volt and the current becomes 400 milliamperes. So we have two cases, right? We'll take I1 V1 and I2 will become 400 milliamps and the voltage will become 1 volt. Now calculate the resistance of the filament in each case and account for the difference. First we'll go for the first supposition. Okay, R1. Okay, using these two we are going to find R1. R1 is equal to V1 by I1. So that is nothing but 0.2 divided by 100 milli. What do you mean by milli? That is 10 power minus 3. Now I'll write this one. 0.2, 10 power minus 3 becomes 10 power plus 3 by 100. So this becomes 2 into 10 power 3 becomes 200 divided by 100. So answer will be 2. What we are finding? Resistance. So unit will be ohms, 2 ohms. In the second case, R2, the same method, V2 by I2. V2 is 1, I2 is 400. Okay, milli means 10 power minus 3. So this becomes 1 into 10 power 3 by 400. That is nothing but 1000 by 400. 2 zeros, 2 0 will get cancels. So this will be 2.5 ohms. That's it. So we found the resistance in each case, but there is one more question. Account for the difference. Listen, why there is, even though the change in current and change in voltage, we are talking about the same material, same wire, right? Then why does the resistance changes? Because the change in temperature, when the current increases, the temperature of the wire increases, correct? If that increase in temperature will result in increase in resistance. So answer for the account for the difference is increase in temperature will also increase in resistance. Now we have completed all the numericals from the chapter electricity part A, and after that, see, the concept video and the theory solution for the same part will be available in the description box. After that, we are going to solve concept, we are going to learn concept, we are going to solve theory questions and numericals from part B, and again it repeats for part C. All those videos will be available in the description box. Watch everything, learn completely so that you will be ready for the board exam. Thank you.